All right. Now I am going to share my space, share my screen, which is always a little bit scary, to the internet. Oh, I can't share my screen. I guess we're limited to one screen share at a time. Is that correct? Oh, wait,
Possibly. Raf's sharing his screen right now.
Raf, you need to unmute on Discord.
Sorry. Yeah. So yeah, you share your screen.
Okay, let me see. Share my screen. Oh yeah. Do you want to drive or should I drive?
You start, then maybe I take over.
All right. Damn, it's super annoying. You can't mute a phone when it's like on a Twitter space, so I can hear like a little buzz of you Raf on the Twitter space. But whatever, I'll just deal with it because I'm a broadcasting professional over here.
I can mute myself on the Twitter space.
Yeah, I don't know. Whatever, it's fine. Okay. Yes. I guess we're like ready to go. We're ready to start.
Yes.
Yeah. So yeah, welcome everybody to the Ordinals Coding Club. Yeah. I think that it's very confusing to know like how development of Ord works and how we write code and how we write tests and how we navigate the repo and where everything lives, and it's all very scary and unapproachable. So what me and Raf are going to do today is, oh yeah, I am Casey Rodamore. Charlie is a Ordinals appreciator and always has helped out a ton with the Discord. And Raf is the lead maintainer of Ordinals. And so yeah, we're just gonna go through some code, and hopefully it should be nice and elucidating for all involved. Yep.
Yes.
Raf, what should we do first?
I think let's start with just reviewing simple PRs. I think we have a couple in the repo. I think the first one we can look at is from. It's called
Actually,
the
maybe
add
just
Python.
just a little review of the code base first.
You want? Okay. Yeah. Sure.
Yeah. Damn, I really need to figure out how to mute this thing. How do I mute this?
I'll mute myself on the
No,
Twitter.
no. Wait, I figured it out. I can put in my headphones into my phone. Oh, no, I can't because then.
But you don't have to listen to the Twitter space. You can just listen to the Discord.
I can't mute my phone though. All the way.
Yeah, it's a thing with Twitter that you can't actually silence the sound coming from your phone. So maybe go hide your phone in a different.
Yeah, just do
but then
down.
it won't hear. Nobody will hear the audio from the phone. They won't know that like
if you do
happening.
the lowest setting on the mic on the speakers and just put it next to you, and you have like earphones in, you won't be able to hear it. I think.
No, I can still hear it. Maybe if I'll just. Yeah, then maybe just mute.
Yeah, I will mute.
Okay. Cool. Perfect. Yes. So Ordinals. What is it, right? Ordinals is a protocol for tracking rare sats rare and common on the Bitcoin blockchain, and assigning numbers to those sats, and furthermore for creating inscriptions, which are digital artifacts, art objects attached to sats that can be transferred in normal Bitcoin transactions. And the sort of reference implementation of that protocol is Ord. Ord is a computer program, like many other computer programs, that me, Raf, Liam, and other contributors wrote and have worked on. And so Ord can be found at github.com/ordinals/ord. If you've never checked out GitHub, GitHub is basically like social media for programmers. So it's a place where programmers can, work on code, discuss code, merge code into a code base. And so the first thing you'll see is you'll actually see the files, like the folders and files of the code, and then comes the README. And I program in the terminal, which is an ancient text-based interface to your computer. And you can see all of the files here inside of my copy of the Ordinals repo. These are actually just the same files here. So it's sort of a one-to-one mapping. The repo, probably there isn't too much to talk about. Ord is written in Rust. So Rust is all controlled by this cargo.toml file that gives the name of the project and some metadata. And then it also gives all these dependencies, which are the different dependencies that are used in Ord. And then all of the actual source code is in this src subdirectory. If we look inside of src, you can see a lot of random stuff. These white files, these .rs files, these are the Rust source code files, and then the blue files are the directories, which are where other files live in. The interesting, files all are sort of have to do with their name, but there are some significant subdirectories. There's the index subdirectory, ll source index, which has stuff related to indexing. The index is the database that all of the inscriptions and the ordinals are stored in. Source index updater has to do with code that updates the index. And then if we look at src again, src runes is all the stuff related to runes, which is sort of quarantined off in its own little happy subdirectory. Runes is, of course, in progress. And then source subcommand has all of the subcommands that you run. Generally, every subcommand is in a file. So ord wallet inscribe, ord preview, ord server, ord index. These are all subcommands of the ord binary. And these all live in these different files in there. And so, for example, you can also go into, like, for example, ord subcommand wallet. This has all of the wallet subcommands. And then inside of ord subcommand inscribe, we have batch, which is for batch inscriptions. Let's see, is there anything else interesting in there? Oh yeah, and then there's the templates. The templates are the HTML templates. So they have some, like a corresponding Rust file inside of src templates, and also in the top level templates directory, this is where the actual HTML templates live. So for example, if we look at source templates inscription.rs, this is sort of this is Rust. Rust is a programming language. It's very nice. This is a struct, also called a record type, which is a way of, having a bunch of named values together in a single value, sort of like an agglutination of a bunch of things. So this is what's needed to render the inscription page on ordinals.com. So if we go to inscription 0, you can actually kind of see all of these fields like ID, address, output value, SAT. These all have corresponding entries in this field, in this inscription HTML. So for example, the inscription ID is this ID here. The address is somewhere in here. I think that's in the TX out.
No, it's generated from the from the output. Yeah, exactly.
Yep. We have the SAT is right here. And so every time you want to render an HTML page, you just get one of these structs together, and then you render it. And then let's look at the actual inscription.html. This is a template. So this is the HTML sort of template that you take. It has sort of, it is a template for these HTML pages. So you take this template plus one of these Rust structs, and the Rust struct is used to fill out the things in the template, and then you serve this page. I think that is a good overview. Damn, the degens in chat are going ham. Raf, you got to look at chat.
Wait, yeah, let me look at the chat.
Yeah, let's see what's going on in chat. Everybody in here. What, pray tell, is a terminal?
Strongly tipped is amazing.
Issues for the stream, PRs for the stream. Eloc is... oh yeah, okay, yeah. We've also started marking issues on GitHub with like good with the stream stream label.
Label.
Yep, and those are the things that we think are good fits for doing on the stream. So feel free to suggest things that you're interested in. Rotomore, a fake account that needs a ban.
Already
that's
nuked.
definitely... Oh yeah, okay, sweet, nice. Subcommand folder, Rust is Bay, yeah, absolutely, Rust is great. Templates folder, nuked. Rust is all the complexity and powerful of C variants and all the strongly typed OCD of Java. It's even more strongly typed than Java, though, which is great. Okay, sweet. Awesome. Great. Okay, so that brings us up to the present day. I'll try to look at chat like a little bit, but it's going to be hard. Dude, it's sweet. There are so many people here. This is rad. Thank you all for joining us.
82, nice.
Yeah. Cool. Let's see, Raf, should we get into our first... Oh yeah, a little bit of GitHub terminology. So, GitHub has the code, and there are sort of two main ways that you interact with a GitHub repo. One is via issues, where inscription IDs are potentially unstable. Cypher, I know. I know. Yeah, this is true. Yep.
We know.
Anyways, that's fine. That's fine. It's not an issue. But so you have issues, which are either bugs and problems with the software, or you have features that you want to add. And so this is a place for sort of discussing things that need to be done to the code base issues. Then you have
maybe talk about the labels that we have. Like
sure, yeah.
Different labels, yeah.
Yep.
Yeah,
so issues can have labels. We've got issues like bug for, these are, I'm sure Ord doesn't have any bugs. These are all just, spurious. But if there were a bug in Ord, it would go under the bug label. And then you have the documentation label. There are we have perfect docs or, some things about docs. Then we have the enhancement label, which is for things how Ord should be enhanced. Then we have the good first issue label. If you're looking to contribute to Ord, go for a good first issue label. These are things that are usually bite size or sort of easy to understand or explain. And then we have process. I guess this is thing for like, I don't know. Listen, I make labels and then they just sit there for a while. And then we have stream, which is the label for things that are good for doing on stream. Raf, any commentary over there?
No, this is perfect. We added the stream label today. Kind of went through, see what we can share with you guys. That's not too complicated.
Yep.
Yeah.
Cool. Awesome. And then pull requests. These are the way that people request that features be added to Ord. They sort of make a change and they make a pull request. In general, I don't think that we do a very good job of getting pull requests merged. It's hard to review PRs, and a lot of the time they take a lot of back and forth with the contributor. And then also we have pretty exacting standards for code. In particular, we write a lot of tests, and we have automated tests for every feature in Ord that we write. And so features can't go into Ord until they have a test. Even bug fixes, we add it, like let's say something goes wrong with Ord, we both add a fix for that bug, and we also add a test so that we don't wind up breaking that in the future. I think in general, probably testing has been the biggest hurdle for getting code merged into Ord. We have a lot of great PRs that get submitted. I think we have some PRs that are open, that are good additions to Ord, but that don't have tests. And the issue is that if you add a bunch of code without adding the corresponding tests, you get into this point where it becomes very hard and risky to change the code because you have very little confidence that the tests are not, that you're not actually changing or breaking the code.
Yeah. Like tests are really important. Like it makes us more confident in refactoring. Like we just finished a huge refactor of like the inscribe command, where we basically ripped everything out and wrote it like new, but we could keep all the tests, and that made our whole job more easy. Because we also, you can also talk about the feedback loop between testing, changing code. You'll see it later, but like that we always run tests while we write code. You make a change, you see if the test passes, and you can it's a very quick feedback loop to make changes. That helps a lot. Yeah.
And you kind of don't need to think too hard about the changes that you're making. You we have so many tests. I'll just do in the terminal over here, I'll do
from the CI.
do a full test run. So first it lints the code base and formats the code base. It makes sure that there are no sort of style errors. It formats the code base so it has standard style. And now it's going to run all of the tests. So these are all the tests, and they just flew by. All these tests that test different aspects of Ord, from inscriptions to the server to the wallet, etc. And they're all going. And then almost always, one of these tests will break when you make a bug, ideally. Yep.
Yeah. Talk about maybe Just. That's a really good tool to kind of, if people want to contribute, like the
Yep.
Just file.
Yep. And unfortunately, we do have some flaky tests. So for example, this test failed, but this failure is not like indicative of a problem. This is just because our tests are shitty, and we should really fix this. All of these things that that fail periodically, they're sort of annoying paper cuts. And oh, somebody says that, okay, somebody can hear me, so that's good. But yeah, they're sort of paper cuts, and just due to the fact that we don't, some of them are like flaky. We also use this tool called Just. Just is another program that I wrote. You can find it at github.org/kc/just. Just is a clone of make, for anybody who knows what that is. And it's basically just a convenient way to store commands and then run them later. So for example, we have this like CI command that runs the test, and that says like, okay, do the clippy command and do the forbid command and then do all these things. And then I run, or I'll just open the just file and get on the right side. And when I run just CI, it runs those tests. So this is a good way to kind of get into, to sort of figure out what the commands are that you will need to run as you are working on the code base. So there's this watch command that I really like. So what does it do? I'll just run a watch with the tests, and this will run a command every time the code changes. So let's say I have some sort of like bug, and I do like, okay, this is self.0+1. When I make a change to the file, the watcher will run the tests whenever it sees a change to the file, and now I can see that I introduced a bug, and so zillions of tests are breaking. In fact, like all of the tests are breaking. And now if I fix it, it'll rerun it again, and then you will see the tests run again, and they're all green. So this kind of gives you an overview. You can see that how to run the tests, how to format the code, how to lint the code, how to deploy, how we deploy it to ordinals.com, how you can get some log files from the server, how you can run the fuzz tests, how you can build the docs, the steps that we do in our releases, all this kind of stuff is there. Yep. So there's good stuff in there that kind of gives you an idea. And also, like if you're just a programmer, you program other things, definitely use Just. I'll fucking shill it now. It's a great tool. It has really good error messages. It's basically like a clone of make, except optimized for the like command running use case. Yeah. So yeah, Raf, what next?
Yeah, that was a great overview. Then let's apply this and look at a PR, no?
Okay,
Kind of
sounds good.
see. Yeah, just go to the PRs and maybe go to the I think the add Python. Something with add Python media type.
Let's take a look. Add Python media type. Awesome. So to give a little bit of background on what this PR is doing, we have this media enum, which is the different types of content that can be in an inscription. So an inscription can have audio, it can have code. Code doesn't get executed, but it does get a nice code highlighting. You can have an iframe, which is used for HTML and SVG inscriptions. It can be an image, markdown. Thanks, Eloc, for contributing the markdown rendering. It can be a 3D model. It can be a PDF, text. It can be some content that we don't know, or it could be video. And then we have this table, and this maps all of the different content types to the appropriate media type. I think I can like maybe, how does this work? Yeah, nice. So this is the first one is the content type. The first thing in the table in the content is the content type. The second thing in the table is what general media category it goes into. And then these are the file extensions. So when you do ord wallet inscribe file foo dot mp4 or meow.wave, it uses the extension to look up the entry in the table. So it'll go, okay, it's a wave, so that means that it uses the content type audio wave and that it should be previewed as audio. Dude, OrdinalOS says .midi, please. I want MIDI. There's an issue. Somebody just needs to open a PR with something that plays MIDI files, and we can have them. I want all tracked music, like old tracker music. But there needs to be a JavaScript implementation that can actually play it in the browser. So what is this PR doing? This PR is for adding a Python media type. So add Python file type. We can go to the original issue. So this says there have been Python inscriptions. I'd love to eventually be able to give them syntax highlighting. We should add text/xPython, which is the content type for Python, to the media type and render it as text. So this is a PR by eloc. Add file type Python. Eloc writes rafjaff. Let's get into this in a second, and then let's take a look at the PR. So this adds Python to the media table, and then we also have this code preview that imports this preview code. Imports like a highlighter, like a syntax highlighter, and then registers it with the render that we're going to use. And then if includes Python, language Python. I think we can make this better. Maybe we could do that now. I don't know. We'll see. So this adds it. This looks good to me. I guess the confusing thing here is that Python has text/xPython as the media type. And so this can no longer just take the second half of the media type. It has to check if it includes Python as the media type, because Python is not equal to x-Python. Yep.
Yeah.
I think we can maybe just do like a couple small things to this and then merge it. This should be sorted, and maybe instead of using language.includes, we can just use language equals x-Python.
Okay. I mean, I don't know if Eloc's here. If Eloc wants to do it, he can do the changes. But normally, if it's like small things, we just pull in the branch locally, make the small changes, and push it. Either way works.
Yep.
Eloc is here.
I just invited Eloc to speak if he wants to come up on stage. Yo, what's up, dude? How's it going?
Yo, how's it going?
Going good. Let's see. So feedback on this PR is just that this should just be sorted, just alphabetically. We keep this sorted. And then what do you think about, instead of doing if language.includes Python, if language equals x-Python, then language equals Python. And then maybe put it into curly brackets so that it's like, I don't know. This always spooks me out when it's the uncurly bracket if statement.
You mean like a ternary?
No. Just like if language equals x-Python, curly brace, new line, language equals Python.
Yeah. Let me pull up my PR. Yeah, maybe you can go over the code quality, like alphabetical.
Oh yeah, sure. So yeah, what editor do you use?
Yeah.
Like VS Code.
Oh, okay. I do not know how to sort things in VS Code, but I guess this should go at the
At the end, X
yeah
is pretty. Oh no, it's text. We sort by the first. So T.
yeah. So it'll be
Yeah.
the right after text plain.
Yeah.
Do we even sort this? Do we even sort this?
I don't know.
Yeah, it looks like we do sort it.
Okay. Yeah. Yeah. Just let us know when you're ready to go, Elok. Dun, dun, dun. Oh yeah, maybe the preview, the static and the preview stuff. We can briefly touch on that. Like
In the
that's just like
preview.
how to render some stuff. Like in static directory, there's a bunch of like small JavaScript things
Yeah,
that help with previewing different types of media types.
yeah.
So yeah,
Yeah, go
And I
over
guess
that folder, yeah.
yeah,
which folder?
Where the static files are for
Oh yeah,
the server.
or the templates folder.
Yeah.
So whenever you're looking at whoops, look at templates preview star. Whenever you're looking at the Ordinals homepage, there are two ways of rendering things. Let's take this fine. Is this Ben Franklin or something? Based Ben Franklin. This is rendering in a preview, which is just like a way of displaying the content in a nice sort of way. And for each different content type, we have a different preview file. So I'll just go through the sort of order of things. So first we get into this preview function in the server, or actually I'll just go to here. So this is the route. It's registered in the server. All of the different routes on ordinals.com are registered here. So this is a route for /preview, which is where the previews live. And then this colon indicates that it's a path argument. So it's whatever goes after the preview. So for example, here, you can go to preview, and then
also click on it. Yeah.
And then this will be the. It's playing some shit about Bitcoin as quantitative easing, and it's all. I think it's Michael Saylor talking. Very nice. So yeah, so that is what renders that preview, and then let's go to the actual preview function to see how it works. It's so annoying to switch windows on a Mac. Okay, so the preview function, it takes a few things. It takes the index, which is the database. It takes a config, which is like the server's configuration. And then here it takes a path, which is the path, which is the actual inscription that you're rendering. So first, we check if the content is forbidden. We do very, very little censorship on ordinals.com, but some things we must censor. So if it's hidden, we just return this preview unknown HTML, which is just sort of like, yeah, this thing doesn't have a preview. Otherwise, we go to the index, which is the database. We get the inscription by the inscription ID. We deal with the case that it's not found. And then we match we get the media type, and we then match on the media type and figure out which general media type it is. Media type audio, media type code, media type image, media type markdown. And then, for example, if it's code, which is what Python is, we serve this preview code HTML struct to, this is the thing that actually gets turned into the page. So that lives in src templates preview.rs. And if we go there, you will see that there is this preview code HTML struct. And then that gets instantiated from this template slash preview dash code dot HTML. And then that's how it works. And then you sort of get this preview that gets filled in with the code. Let us take a look here. And then we have, yeah, so that's the full sort of thing through it. So yeah, let's get back to the PR.
So I was supposed to commit, is that what you were asking?
Yep.
Yeah.
Yep. Awesome. So now this is in the right place. So we just got the changes from eloc. So this is ordered right. It's text slash xpython. Media type is code. Extension is py. This looks good. And then we do this. We get the Python thing. I guess we should sort these two, because why not?
Casey loves sorting alphabetically.
Yeah, I love sorting. I'm like very OCD about this shit. Yeah, I guess sort this and sort this block as well.
Yeah, in Vim it's always just like colon sort and then it's done.
And then for here, do if language equals x dash Python. It's a slightly more I think it's slightly better to test the exact value instead of just something that includes Python. Ugh. Bro, it's not cosplay, Charlie. I am the Liver King.
Yeah, Casey does not have a sunburn for everyone who's new in the chat.
He does have the muscles.
He's cosplaying today. Yeah.
Yeah. Here, wait, I'm gonna go get a snack. I'll be back in a sec.
Is it raw meat? Yeah, thanks everybody for joining. There is a Twitter Spaces, and if you hop in the Twitter Spaces that Casey is hosting, it will and just mute yourself. There's no talking in it. You can kind of elevate and augment the fact that we are having this Ordinals Coding Club.
Yeah.
Okay, it should be good now, Raf.
Okay. Yeah, I can't share my screen. I mean,
Oh yeah.
Casey's sharing his screen. Like normally, the way we code, we both kind of share our screens. I look at his screen and at my screen, and he looks also the other way around. And then we can always like very easily share and talk about code. It's yeah, it's really nice. But I guess on the stage, only one person can share.
Yeah, so we did this PR on
cheese.
We did this PR in our workshop at Describing Amsterdam. So if any of you people were there, this is the second half of it. So yeah, if you want to add a media type, it's really easy, low hanging fruit.
Yeah, so now you have two videos, I guess. Like, did you take a video of you inscribing it at Inscribing Amsterdam? Of you making the PR?
No, I don't think we did.
Oh, okay. Yeah, yeah. Okay, Casey, I think this is ready.
Yep, looks good. Yep, these are sorted. These are sorted. This has the sort of more expressive or more.
So what are we gonna do as we have like more languages, and then this just gets really disgusting? I think I have like a talk about
if we get a lot of languages, like right now we're doing like every language explicit because we want to kind of save bandwidth on for the browsers to not like import all the syntactic highlighting libraries. I mean, if we get a bunch, we can like switch back to auto highlighting. Then the JavaScript will kind of.
I think I know the right way to do this. I think what we do is we take the preview template struct, and we actually add the language. We can have like a language enum, and then that gets instantiated in the template, and then in the actual template, instead of static preview code, instead of importing all of them, we'll have then the language as a template parameter, and we just we just request the only language that we're using, register the language, and render it. And we could always include in the template, the content of the inscription in line, so that this doesn't even need to make a request to back to the server for content. All right, awesome, looks good. So I will approve it. And the way that reviews work is that everything always gets reviewed by at least one of me or Raf. So if somebody opens a PR and it's a pretty straightforward PR and I see it, I'll probably just review it and commit it. If Raf sees it, he'll review it and commit it. If I write code, I have to get it reviewed by Raf before it goes in. And if Raf writes code, I mean, he can do what he wants. He's the maintainer, but usually I'll review the code because it's like, code is complicated and we get things wrong. So we always want to, not mess anything up. So let's see. So once the code is submitted as a PR, these checks run. These CI, which stands for continuous integration. And these are just checks that run on every PR that make sure that the code doesn't introduce any bugs. So for example, what's in here? It's in .github/workflows/ci.yaml. And these are all of the checks that it runs. It builds the docs, it builds the code, it formats the code, it checks for lints, it runs the tests. So what I'll do is I'll hit enable auto merge.
Wait, should you check on regtest to see if it's rendering?
Oh yeah, I guess I should. Let's see, touch foo.py, then foo.py, print hello world. No semicolons in Python. Regtest, scribe, run regtest, foo.py.
Do you have a regtest node running?
Yeah, I always have a regtest node running.
Yes.
Yeah, for people that don't know what regtest is, it's like a local blockchain running on your Bitcoin node, and you can run ord to test it out. It's in that Ordinals handbook
in
under
test
testing.
Yeah. Do a cargo run.
Yeah, you can run Bitcoin D. So like you can be running your Bitcoin node and you can run regtest Bitcoin D.
Yeah, it's very good to like test your inscriptions as well, like to see if they render correctly the way you want to display them. We also have a preview command that kind of bundles everything that together. So you do ord preview and then your inscription. So it starts the regtest node for you, inscribes it, and then opens the browser window with that inscription. So if you want like a full packaged command, you can use the preview command. But you can also follow along the guide under the testing header in the Ordinal Theory handbook. And it gives you more control of what you want to do. And you can inscribe multiple things. I mean, in the preview, you can also inscribe multiple, I think. But yeah, those are kind of the two ways.
In general, I would suggest everybody should be using regtest more to preview things. It's really fast. It's really simple. You can do it locally. You don't need to get coins for Signet or testnet. So I just ran this inscribe command. It gave me this output. And then I need to do this generate Bitcoin CLI regtest generate to address to actually mine a block. So this will mine a block. And now I can do server.
Server, yeah.
Cargo run regtest server. And then jopen will open in a browser. And yeah, you can see some nice Python syntax highlighting here. We should probably do the same thing that we do with the text previews, where we make them fill up the screen.
Yeah.
Also, I'm going to shell ord package manager in the chat here. So like it automates a lot of that regtest.
Manager?
So like it downloads inscriptions that are like packages, and then it like automates a lot of the regtest commands.
What? Like what does it do?
So like you give it a JSON file of like what inscription ID of like say matter.js, and then it will download those, inscribe them to regtest, and then there's like a template HTML file, so it'll like inject the regtest inscription ID. So then you can like test recursion like pretty quick and test out libraries.
Dope. Dope.
Very nice. I still have to play around with it. I haven't tried it out yet, but I want to. It's on my to-do list.
Yeah, it was broken yesterday, and I
OPM.
thought
Oh,
JavaScript
okay.
is that issue I made yesterday.
But it
You're like, are
was
you sure you have
resolved,
JS file? Yeah, and I patched that in OPM.
no? Okay, awesome. So, yeah,
So
this
this
is just
should,
gonna run.
yep. Should we go to the next issue?
Yeah. So now let's look at a little bit more complex issue, or not issue, but a PR. It's one by Liam. It's the implement block query JSON endpoint.
Okay. Let's see. So what is this doing?
So I think yeah, we have these the JSON API, which you can enable with the -- enable JSON API flag on Ord, and we're kind of slowly building it out. It's for people who can then you can then talk directly to a server and like send a JSON request and get like JSON back, and it makes it easier to kind of build tools on top of Ord. And this is one endpoint where it's the block endpoint, so it just gets a block and all the information that's associated with it, and the information it passes back is very similar to what you get when you go to the block one on ordinals.com. I mean, you can have a look at ordinals.com/blog/give it a block, Casey. And then, yeah, you can either pass in a block hash or a block number. It'll kind of figure out which is which by matching. And then basically this is the information we're expecting to also see in the JSON output. So it should have a hash, a target, timestamp, size, weight, and some inscriptions and some transactions if they're contained. Yeah. So let's see what Liam did there.
All right, let's take a look. So added this block JSON thing, this block JSON template, and then passed accept JSON to the server, to some path in the server. This is a block path. If we go, well, all the way up here, here you can see we have this block route. That's what routes it to this block function, to self block. That's the actual function.
Maybe go to
So
the
then-
function and show the query, what the query does. That's maybe interesting. Maybe not, I don't know. That it matches either the block hash or the block number.
Let me get it in my code, in my terminal.
There's also a really nice tool, the GitHub tool. It's GitHub, GH.
GH.
And then you can check out PRs, and it directly loads it and checks out the branch. It's very convenient.
What should I look at, Raf?
The query, like go to the block function in the index, in the server. Yeah, and then just how the query works. I don't know. Like you can either pass in a height or a hash. You see that? Yeah.
Yep.
Yeah, exactly. Like you can match on different things. Yeah. I mean, yeah, it's not that interesting. I thought it would be interesting. But yeah, there's some. Let's look at the PR again.
Let's see. Oh, yeah, okay. So then we have this, we parse the query here, we match the query, and then we get the featured inscriptions, which are just the highest paying inscriptions in the block. And then if it's JSON, we construct a JSON response using this new block JSON struct with the block, the height, the index height, the total number, and the featured inscriptions. Otherwise, we return a normal HTML response. Let's see, server, cargo run, regtest server. I'll just see this in action. So I'm running the code. I have the code from the PR checked out.
I mean, if you want to do, you have to do enable JSON API if you want to see test the actual JSON API.
Let's make sure that that flag actually works.
Okay.
J
I
open,
hope.
and then we can go to this block. Oh yeah, and I guess I will have to curl it. How do I do accept?
I think -X or something for header. I always forget. It's
I
a
linked the
typical
docs in the
ChatGPT
chat
question.
for the.
Oh yeah, we have it. Do we have it in the docs? Probably.
Yeah, I think you added that, right?
I don't see it in the chat. Oh wait, there it is. Here you can go to the docs, Casey. Our docs. Look in the chat.
I think I
Okay,
found
Amy.
it.
It's -S -H and then the accept application JSON. And then capitalize the accept and then colon and then application JSON. Application/JSON. Yeah.
I don't think
Or maybe it doesn't. Yeah.
headers are case insensitive. Header names are case insensitive. Okay, so now I have to do JSON API.
Enable JSON API.
It should just really be API.
Okay, we can change that. Or maybe, what is it? To go to help, maybe? Just do the help -help, and you'll see what the flag is.
I think you got to put it before server.
Why is it before server?
Oh yeah. Get rid of the help.
Okay. Oh yeah, now I can curl it, and we get this thing.
Do a JQ, then it's nicer.
Why is why does the enable JSON API, why is that not on server?
Good question. It should be. I don't know.
Let's see. So I'll just create an issue.
Like on the server.
I always like making things as like terse and unreadable as possible. I like short names, so I prefer yeah, maybe
API
it
is a
should
bit,
be --JSON API.
Yeah.
Yeah, maybe enable JSON API is fine. Okay, I talked myself out of it. Okay, so this looks good. I would
Let's look at the
rename
PR.
some fields. Let's see. So we have this block JSON thing. Let me refresh it. This block JSON thing, and then we do add the accept JSON flag. Is it in the accept JSON flag that we like? How do we determine?
This is the acceptor.
Yeah, how does it get the JSON API enabled flag? It gets
Through
the
the options.
state. Yeah, but how?
It's passed in the extension, like on the server. So if you go to the server to the routes, go all the way to the bottom of the routes, it's passed in as an extension. Go to the routes. Wait. Yeah, there, and then I think it's passed in here somewhere. Extension.
The config?
Yeah, it might be in the config.
Arc from rent state. Ah, yeah, state is the server config. Okay,
Yeah.
cool. So it has access to the server config. Okay.
Yeah.
Okay, so we pass in accept JSON. Where do we pass accept JSON in? It's always last? Okay, that's fine. Then we do this. This looks fine. I want to rename some things, but I'll look at that in the actual place where they're named. We have block HTML as well as block JSON. Okay, cool. And then we have We go from 2 LE bytes to 2 BE
That was
bytes.
that was the issue with the targets. So wait. No, I don't think this is.
That's the target. We weren't
Yep.
showing the target correctly. But now, in the most recent pull, you can see that it's aligned with the where the hash actually needs to be less than that. So the way that difficulty works in Bitcoin is that each block has a hash, and then the hash must be lower than this number, which is called the target. And as Bitcoin, somebody's commenting on my rice cooker. That's not my rice cooker. That's my Instant Pot pressure cooker. My rice cooker is off screen over there. So each block must be below this difficulty target. And like fun fact, if you go to the Genesis block, it's not, my shit's not running anymore. It's just server, sure. You go to the Genesis block. Genesis block was actually significantly harder than it needed to be. It could have had even a big old 7 right there, but it just has an F, so it's way under the difficulty. Oh yeah, no, this is fucking regtest. What am I doing?
This is regtest.
Listen,
this
forget
won't
I
tell
said
you
all
anything.
that. Forget I said all that shit.
You can go to ordinals.com to look at it.
No, but then the target's going to be backwards.
Oh yeah, true. We have to fix that.
Yeah. So this is good. This fixes that. It has the block JSON struct. We have the hash, the target, the best height, the total number of inscriptions, and the featured inscriptions. Should the featured inscriptions be part of this? Should the featured inscriptions be returned by this API call?
Yeah, so in the HTML, we only show the featured inscriptions because it's just like we're loading the HTML and don't want to like load a bunch of inscriptions. I think what in the JSON, we could just return all the inscriptions in that block just as a list of inscription IDs. I think it should be fine. I mean, it's like a block has no more than, I don't know, 6,000 transactions. So I think it shouldn't be too heavy on the server. So I think we could, instead of the featured, return just the list of all inscriptions in that block.
Yeah, that's also nice because we could also get rid of this total num inscriptions. Total num inscriptions field. Hash target best height. I wonder why we call it best height. It's kind of weird. Why do we call this? Well, yeah. Why do we call this best height?
Go to the HTML. Like open up, go up a bit. Like, do we have that in the HTML as well?
Yeah, we do. Yeah.
Good question. I don't remember. Like, yeah, coding is sometimes very, I don't know. There's a big code base and it's something very ephemeral why you made choices. That's why you need good tests. Like you forget why you did something.
Yeah, code bases, they start off like pretty understandable and you know how everything works, and then as you work on them, they just basically become like spookier and spookier haunted houses, and you don't know, like you don't remember what you did, and you don't remember how things work. So a lot of the time, you know, doing something that to code, when even me and Raph go back to parts of the code, like I don't remember how this shit works. Like I don't remember why we made the decisions that we did. Okay, so all of this looks roughly right. There's a few things that I want to change here. I think maybe block JSON can just have the hashes. They can just have the block hashes, depending on how those things render. And then we can maybe change it to return all the inscriptions. So let's go back to this block endpoint. So we have this get featured inscriptions, get highest paying inscriptions in block. Did this change? Did the
No, it shouldn't have changed.
Or sorry, just something in server. Oh yeah, okay. This was there before. Okay. So let's go to the index and see if we have a way of getting inscriptions.
We do.
Get children by inscription ID, get inscription IDs by SAT, by sequence number, by inscription number, by ID, inscription exists, on output, get inscriptions for some UTXOs, inscriptions with next, get inscriptions in
In
block.
block. That's the
Okay.
one we want.
Got it. Okay. So then we can do, we'll move this into this branch. And then I always program with a watch. This is like my programming setup, is I have the code on the left, and then I have the terminal on the right with a watch. And at first I'll just do a check. I use cargo limit, so all my commands are prefixed with L. It kind of gets me jump to error in Vim with some other horrible scripts. I'll run a check --lib, so it's like really fast. And so this will let me like iterate on the code quickly while I'm just doing things. And it's pretty nice to just make a small change to the code. And then it's not right, it's wrong. I just move this shit into this block. It's not here in this other block, but it'll help me sort of know what I need to change. So
And
first thing,
cargo is really nice. It gives good error messages.
yeah.
So it really helps you.
So first thing I'm going to do, I'm going to delete this total num inscriptions, and I'm going to change this to just inscriptions because it's going to be all of them. And I guess I can use a rewrite or a rename. And now I can just start jumping to the errors. So there's no total num, and then there's inscriptions. And what we can do is we do let inscriptions equal index dot get inscriptions in block, and that takes the height. Whoops. And that gives us a vec of inscriptions, which is what we want. So cool. And then we need to go to this block new. And now this just takes as the last argument inscriptions, which is a vec of inscription ID, and
Move it from the struct.
puts it in here in the struct. Yeah. Oh, did I?
You have to remove it from the struct.
No, I messed up.
Not there.
No, I know. I messed up
Okay.
the block HTML because I put this. God, I hope I didn't rename it. Let's see. Now we go to block JSON, and this has inscriptions, which is a vec of inscriptions. See what happens. Block, and this is featured inscriptions because we changed it back. And I don't like this total num inscription. We need to do inscription count. Raf?
Sorry.
I don't like this total num inscriptions. I think it should be either total inscriptions or inscription count.
I mean, in the HTML, you want to change that as well. Yeah, make it a count. I like inscription count more.
Yep.
Yeah.
Okay. This is going to cause an error in the template. So whenever you change one of these template structs, this is a library called Boilerplate that I wrote that generates like pure Rust statically checked templates. So whenever you change a field in a template struct, you'll probably get one of these sort of annoying errors that just points to the boilerplate derive macro. And so that's where you have to fix this thing. So inscription count. So there we go. That fixed that. Oh, really? Okay. Cool. And so for small changes like this, and especially because we're doing a stream, we'll just kind of like fix up PRs in like little ways. There's sort of like debate on whether you should do that in an open source project. But I think it's nice to get people's PRs merged. And if we make substantial changes, we'll try to comment on the PR with like what we did. Oh yeah, so git add -- patch is really good. Git status. Yeah, so git add -- patch, which I have alias to gap, it will add things to, it will stage things in the Git index, and it'll do it piece by piece, so you can sort of see what you're staging. I just find it really nice to sort of do staging in this like interactive way. Okay, so you can see we move this this into the else, where we're constructing the block HTML. And then here we have let inscriptions equals index got get inscriptions in block, and we change that. So that looks good. Inscription count we changed, inscription count we changed again. And then this we changed to be all inscriptions instead of just the featured inscriptions. Block JSON has this, inscriptions has this. Inscription count, featured inscription.len. Okay, cool. Actually, I won't commit yet. So one other thing I noticed is that in block JSON, we have this hash and we have the target. I kind of think that maybe this can just be a block hash. I don't know for sure because I don't know if it implements serialize. So we use serta for serialization, which these right here are called derive macros, which generate a serialize and deserialize implementation. So I think maybe we just do this. If we can get away with using the actual type, we should.
It's a question, how it will be displayed then? Like in the JSON, it might display as like a vec of bytes, which is kind of ugly,
Yep.
to be
Yep.
honest.
Yep. Agreed.
So I don't know if we want that.
Yeah. Let's see. We can write a little test for it. JSON hash serialization. JSON or block hash serializes as string, as hex string. And we can just do like block hash all zeros, serta JSON to string that, this, that, assert EQ, and then just make it a string at first. So what we're trying to make sure is that when you serialize a block hash, we want that to show up as a hex string and not something like a JSON object or a byte array. So what I'm doing is I'm writing this test that I don't know what it serializes as, and I don't know like how many zeros, and I don't want to write them out all down. So I'm just going to write a test that I know is going to fail, which is asserting that the block hash, that when you serialize to JSON, you get all zeros. And let's write this block hash serializes. So once if it complains, it'll give me the value that it serializes to. Okay, so here I need to unwrap. And this is like not to be like the Bob Ross of like coding or whatever, but like you don't have to get it right. You just have to get it to the point that the compiler will tell you what's wrong. So it's a good idea to write things incrementally and then just like let you let the compiler tell you what the next problem is and not worry, too much. And it's very nice if you can like jump to error. This is some shit where we have like a block hash and we don't blah blah blah. So we can do like, I don't know.
Yeah.
Block. Does block hash have a from stir implementation? Do you know?
I don't know.
Let's see.
We definitely have to delete the bottom two lines, the total num inscriptions, or rename them. I mean, the compiler will tell you.
Here's some tests. JSON API. See, we don't have total num inscriptions. Just have inscriptions now. Okay. So okay, it does look like this successfully serializes as a JSON string. So that's what we want.
That is cool.
And then I think maybe that also means that we can use it for the target. I'm not sure, so this is something that we'll have to check.
No, I think it might not work because the target is something we want to be displayed in a specific way. That does not support. Like we want this, we want to see like that the block hash is underneath the target. And I think in the serialization format it flips it around so you can't like nicely. It is not nicely aligned. But try
I
it
think
out.
it's
Try it
okay
out.
because you can see right here we do block hash dot from raw hash dot to string, and so the we're doing the setup here
Yeah,
when we
if we
do.
only remove the toString, it maybe should be fine.
Yeah, I think so.
Yeah.
Let's do that. So again, like just let the compiler do the work. You know, I just changed it. Like
Yeah.
okay, it goes okay. This isn't a block hash, so we just delete it, and then we're like yeah, and then is it gonna work? Who knows? You know, no, it's not gonna work. But then we can do here. We go to this dot parse block hash dot unwrap. That fixes that. And then also, yeah, nice. So that looks good. Okay. And then here, yeah, we have this function new instead of just constructing block HTML directly because we sort of have these like transformations that we're doing. Oh, sorry, on block JSON, where we're like doing the tag. I feel like this function could be just deduplicated into a little helper function. So we can do target as block hash that takes. Here's another thing. I'm writing this function. What we're going to do is we're going to kind of encapsulate this. So we're going to go from whatever this block hash header target is, and then we're going to turn it into a block hash. But I don't actually know what this target is. I have no idea what this type is. Who knows what lurks behind this function call? So I'm just going to say that this takes a target and then tell it that it's like the unit type. And I know that it returns a block hash. And the compiler will tell me what it is when I use it. So we block hash from block hash. We're going to do target.toLE bytes. And then now we're going to call our little function.
Target.
Cool. And it turns out this is a thing called the target. Okay. And we need this like target Bitcoin target. Oh, but we already have a target defined elsewhere. So we'll just be more specific and call it a Bitcoin target. Elak, by the way, if you want to jump in and ask any questions, feel free. You can use that here. So we just deduplicate a little bit here. And I kind of forget if there's anything else that I wanted to change. So I'll commit this stuff, push it, and then we'll look at the pull request again. Let's see what I
You can
actually did.
also run
So
the
what exactly
CI
was
one.
this PR doing? It was just getting the JSON for the block.
Yeah, it adds a JSON endpoint to the block route. So you can do .block/query, and it'll get the JSON endpoint for that.
Yeah.
Or the JSON.
I mean, yeah. And this JSON endpoint it's not a real, it's like basically it's served over HTTP on the server. At some point we want to have like ordinate daemon mode so that it's a similar kind of JSON RPC as Bitcoin, but that's a little bit of work. So for now it's just like basically serving JSON over the server. Yeah.
So before this, we just had the HTML for block.
So yeah, people basically were parsing HTML to get information, and through this kind of JSON endpoint, they can now like request the information directly. It's just a cleaner developer experience than kind of parsing our HTML. We do not have it enabled on ordinals.com. We might at some point, but not sure about that. But if you run it locally, you can now kind of like interact with it in a bit better way.
Cool.
Until we have a
So-
daemon, and then it's going to be much nicer.
Yep, so this looks good. Now we have this get inscriptions and block. We're returning all the inscriptions. So it looks good. Here, template looks good. Here, target is block hash. We just sort of refactored it a little bit. Inscription count. We're using this target is block hash. Now we have this. We have this thing called best height. I guess I want to look at why it's called best height. Oh, if self.height. Oh, yeah, best height is the current height of the current chain tip. So this is the way that we see if there's another block following this block. If self.height is left.
Just for pagination, basically.
Yeah.
Yeah.
And best height is terminology from Bitcoin Core. Bitcoin Core calls the current best chain height best height. Yep. Okay,
Longest,
so
heaviest chain.
yeah. So here we go. Block height, best height, inscriptions. Cool. Block hash serializes hex string. This is a little check to make sure that this is what we'd expect. Inscription count. So this looks good. This looks good. We import block hash here. And now this is Liam added a test, which is awesome. So a lot of time when you get a PR, like you don't really know what the code does. And looking at tests makes it very easy to see what a PR does. So here we can say, okay, you have the server, you spawn it with these args, you do this JSON request, and then you get the JSON back. And then you deserialize it, and then you get some code. Okay, looks good. Let's merge it. Raf, looks good?
Yeah, looks good to me.
All right. Cool.
Maybe update the branch, yeah.
Out of date. And merge it. Oops. Add block query JSON API endpoint.
Seems
Okay.
good to me.
Yep, looks good. What's next?
So
How are
yeah,
you like calling Bitcoin in like Rust? Like what library are you using to talk to the core?
We use Bitcoin Core RPC, Rust Bitcoin Core RPC. Oh, except we use the one in from Rust
we
Bitcoin.
use.
Yeah, we use our fork of.
I think yeah, we use our fork because of another thing. We wanted to add some traits to some structs. So yeah, we have a fork. We should open PRs on Rust Bitcoin Core to try to get those merged.
Yeah,
kind
it's
of
so much work
pain.
though. We're never gonna do
Yeah.
that.
Yeah. So yeah, but like that's a library, and that you just create a client and then you call the RPCs. Yeah.
Yep.
So yeah, what next? We can. So there's multiple things. Like we can kind of, if it's interesting, we can comment and walk through the envelope, like the actual parsing. Like it's a core part of what Ord does, is parsing envelopes
Oh,
or
yeah.
inscriptions from
Yeah.
transactions. It's like basically the heart of this. It's basically where the consensus logic lies. So if we want, we could like walk through that and comment some stuff into it. There's
There's a
also
comment
couple
on
other
batch
PRs.
inscriptions. Somebody could run that in regtest maybe.
Oh yeah, batch
Sorry, what?
inscribing. That's the whole thing.
There's a comment on what?
Somebody wants to learn about batch inscribing.
Oh, I mean, batch inscribing is, I mean, I can show something about batch inscribing. I did a batch inscription yesterday.
Just do a little batch inscription.
Okay, I'll do a little bit of batch. I'll just show the thing I ran.
Here, I'll stop sharing my
And
screen.
then we
so you
can,
share your
and
screen.
then we can, yeah, maybe I share my screen. Like this is not really part of the coding. It's just, it's how to use it. I don't know. I guess if people want to know, I can show what I did. Share my screen. So batch inscriptions. Yeah, let's go to the docs. I think that's always a good place to start. Yeah, batch inscriptions is this kind of new way to inscribe multiple transactions. And it uses a new protocol feature called the pointer field. You can see here, we can open it. And basically what the pointer allows you is to point to the specific SAT in the output that you want your inscription to land. So you probably all know we have these nice envelopes, which is where we store all of the inscription data. You have the protocol identifier first, then you have these things we call kind of fields, and you kind of tag these fields with numbers. And the first kind of field or tag we have is the content type, and then which kind of tells you what then the actual data of the inscription is, which is then kind of tagged with a 0, and then it's just the data appended to the end. And now we've added a new field called the pointer, which has the kind of field tag 2. And yeah, this provides a way to kind of point to SAT in the outputs. There's, of course, some considerations here. For example, if you put a pointer that's larger than the output size, so if you have an output size of 1 BTC and your pointer points to 1 BTC and 10,000 sats, it is ignored. But other than that, it can land on any kind of SAT in the output. And what kind of this enables in the kind of simplest case is batch inscriptions. And batch inscriptions work by putting all inscriptions into the same input. So all data is in the same input. So normally we have a commit and a reveal transaction. So we create kind of the commit transaction, which commits to the script. And then the script is then revealed in the reveal transaction, which actually then contains the actual inscription data and the actual envelopes you see here. And the way the batches work, we put them all in the same input. So it's very efficient size-wise because you do not have to have many different inputs. And they're just like after each other. And then, yeah, with that, you can then use kind of use this to batch inscribe a bunch of inscriptions in one go and also separate them apart so that you have them in separate outputs, for example, and then can use them and transfer them normally. And this is very nice for parents or for provenance or parent-child, because as you can see here, you can kind of define the parent once, and then all the inscriptions down here will get this parent as their, will be children of that parent. So beforehand, you would have to like sequentially pass in the children and do everything sequentially, and that was like kind of a pain. And now you can literally have like a batch of 100 inscriptions and then inscribe them in one go in one transaction, very space efficient, and they all have the same parent. So it makes it very economical and nice to work with. And the format to kind of how we do batch inscriptions is with this batch.yaml file. And yeah, we have a couple modes. Kind of modes is kind of the way in which these inscriptions are separated. And the most useful mode is probably separate outputs. So all inscriptions land at their own output. But we also have a shared output one where all inscriptions land in the same output and are only separated by the postage. This is even more, maybe it's not more like, but like, yeah, there's just these different ways of inscribing them. And yeah, so let's have a look at an example. So I think I did
Are
something.
you limited by the standardness rules of
Yeah,
the
of
size
course.
of the
So
transaction?
like exactly. So yeah, that's a good question. Like you're still limited by the standard transaction size weight. I forgot what exactly it's called. It's I think 400,000 bytes. So yeah, you're still underneath that limit unless you know a miner and whom you can like like pass in a non-standard transaction. But that is it's large enough to put in a couple inscriptions, and you can always like split up your batches into multiple batches if you have more than fits into one transaction. I think if you try to inscribe something over the transaction weight, like Ord will complain. So you won't accidentally send out a too big transaction that won't ever be mined. Like Ord will be like, hey, this transaction is overweight or oversized. Please like make it smaller.
So you have to turn that off and hand it to Charlie at Luxor if you want a big one.
That's right. Yeah.
Yeah, exactly. I don't know. 'Cause,
Charlie at
Luxor
Luxor
has a
takes
nice
all the big
API.
ones.
You
Wait,
could
let me
put it that
turn
way,
on.
yes. You can
So
DM me.
there's a question in the chat about
Mhm.
reinscribing. Is there a way where we could get this to do reinscribing on the same sat?
So yeah, I mean,
Batch
this
descriptions?
is a mode I definitely like has been requested. So this would be another mode called reinscribe, and it would, if you pass in a parent, it would inscribe all the inscriptions on the parent sat. If it doesn't have a parent, it would inscribe all on the same sat, all on the first sat of the first output. That would be another mode you can add. Like this batch file, it can do a lot. Like it can be extended in very very cool ways. But yeah, reinscribe is definitely something I was thinking about. Yeah, and yeah, I just made yesterday. I made a small batch to kind of test things out, and this is my batch file. So wait, maybe I can show stuff. So okay, yeah, I guess I think I have. So yeah, this is the kind of the batch file without the comments. I decided to go with a separate output mode. I decided to take a parent. The parent is, I mean, we can just kind of copy this out, have a look at the parent. Inscription. It's like this yellow, I call them Ord bots I made early on. I don't know. This is like some simple pixel art. And this is what I wanted to be the parent of these inscriptions. And then I just found some like really random, I don't know, notes on my computer. I just like random quotes. I don't know where they're from. There's like, I can just open one. Like for God to be effective, he has to be intermittently wrathful. What else do I have? Memory.
I
What
forgot
is
we're
this?
so back.
Karma is the residual impact of memory. Consciousness does not like. I don't know. These are very esoteric. Kneeling. What is kneeling? Like once you start kneeling and praying, it's difficult to stand up and think again. It's over. Yeah, like a bunch of like random shit. And then yeah, basically I inscribed it. I don't want to inscribe this again, but I can show you what I did. So I just did ord wallet. You can look inscribe. Yeah, this is basically what I did. So ord wallet inscribe batch. You kind of define pass in a file that defines your batch, and then the fee rate. And then I added the dry run flag here, which basically just says do not send it out. I can run it now. So you can kind of see what the output is, but this has not been sent out into the mempool. This is kind of the thing that would come back. It would be like this would be the commit transaction. Then these are all the inscriptions and all the locations, and you can see here they're all in different outputs. Like you see 1, 2, 3, 4, 5, all different outputs. We see it has a parent, and I would have been paid 24,000 sats as a transaction fee. We can mempool. I don't know. Is this the transaction? No. Like we can have a look at the transaction in the mempool. Oh man, my history. I mean, there's nothing in here.
I put it in chat, your tweet.
Yeah. Oh yeah. Maybe. Is it this one? Transaction. Trying to find the correct transaction. Oh yeah. So yeah, this is how the transaction looks in the mempool. So yeah, you can see this is the parent. This is the first input. This is the parent. And this is the one input where all the inscriptions are in. And then you can see they're all nicely split out into their own outputs. This is the feed. This is the parent, which is just passed through. And these are the 5 inscriptions. This is how it looks. And then when you go on ordinals.com, this is how it looks. Like this is the parent. And then I have these children down here. We can like just like, yeah. You can see here I added some metadata. Oh yeah, sorry, I didn't go into the metadata. So I wanted to inscribe a file, but I also wanted to kind of add a title to it and an author. The author here is the yellow Ordbot, and just like some fucking random titles. And then you can see here the metadata as well. So here's the metadata, the author. You can add any type of metadata, and you can see the parent is also here. You can click on the parent, and then you're back at the parent inscription. And that's basically batching. So
One
very
interesting
simple.
thing about our metadata is it can actually be any YAML type. So for example, if you just wanted to include a plain text description in the metadata, you could either include that under a key description with a value of the description, or you could actually just have your metadata be a text string, and it would all just get rendered under that. So it's very flexible. You could have your metadata be a single big number, whatever you want,
Yeah.
whatever the CBOR spec supports.
Exactly. So yeah, you can wild out on the metadata. I mean, I think we were thinking about like if we find a field called title or description, we might pull it out so it's not nested, because it's a field that will probably be used often, but we haven't.
I actually think it
implemented
looks
that
pretty good under metadata.
yet. Okay.
Oh yeah,
Can we
and
just leave it? Yeah.
one other thing that people should keep in mind with metadata is that CBOR tag name, CBOR map fields are ordered, and the order in the CBOR is how they will show up in the metadata. So make sure that your metadata fields are in the order that you want them to appear on the inscription page.
Yeah, yeah. One thing you should also know right now about batching is that the inscriptions will be cursed. So if you add a parent, all inscriptions will be cursed. If you don't have a parent, the first will be not cursed, and all the rest will be cursed. That's just because if you use the pointer field, or if you are an inscription within the same input, they become cursed. Yeah, it's just how the curses work at the moment. We do want to kind of get the ball rolling on kind of the Jubilee is what we're calling it, kind of or not uncursing, but like every new inscription that would have previously been cursed becomes a normal inscription, which would work with some kind of activation height. And then after that point, like the curses are gone basically. This probably like we need to give enough lead time for like marketplaces, indexers, and the whole community to kind of decide on a good point to activate this. Yeah, we probably have to start kind of talking about that in the next couple of weeks. But yeah, for now they're cursed. So
This
just so you know. Yeah.
One other thing is that we would really like to avoid going through the Jubilee and then finding new sources of cursed inscriptions that we want to bless. We really don't want that to happen. That would fucking suck. We'd have to do like Jubilee 2 electric glue or whatever, which would be fucking lame. So
Yeah.
exercising edge cases and finding new reasons that inscriptions can or should be cursed would be an enormous help. We would love to find these things early to avoid, Roman numerals, Jubilee IV,
1.
Jubilee C, hopefully not.
Yeah.
In general, actually, one of the best ways to contribute is finding bugs. Bugs are hard to find. There's so many different ways that transactions can be constructed, so many possible edge cases that it would be awesome to any debugging. Also, another way that you can contribute is just by adding a test. If you could go to the code, try to change something that you know is wrong, see if the tests fail. If the tests don't fail, then that is an indication that our test coverage is incomplete. And so you could just add a test that checks that case, and that would be a fine PR. That's actually the easiest PR to just merge, is we see a good test, it's good. And also the style and coding standard for tests is way less like enforced. tests can be pretty ugly code, and obviously we'll clean it up if we can, but it's not the kind of thing where tests don't have to be perfect code.
Yeah. So yeah, that's batch inscriptions. As always, like the docs, we have everything here, kind of the pointer. We also have the metadata kind of explained. And yeah, we also have teleburning now. Batch inscribing. Yeah, just check out the docs. They're pretty extensive. And yeah, we have like a bunch of languages. Like, look at this. There's 2 more coming.
Dude,
So,
it's insane. Yeah,
I think
pretty soon the Ordinals handbook is going to be more widely translated than the Bible. We're gonna make it. We out here.
yes, exactly. So yeah, check it out. Yeah, I mean that's batch inscription. Any more questions on this specifically, or else I would hand it off back to Casey if he wants to continue. I don't know what we wanted to do. Ah, yeah, the envelope thing.
Oh yeah, the envelope.
If that's
All right.
interesting, yeah.
Yeah.
Okay, then I'll hand it back to you, Casey.
Sounds good. All right. So inscriptions live in envelopes. An envelope is just a term that means envelopes live in Bitcoin script in the witness. The witness was introduced in SegWit and improved in Taproot. The witness, I mean, let's just go to like maybe a Bitcoin, someplace that I can find like a little, I don't know, Bitcoin wiki transaction. Let's go here. This is the Bitcoin wiki, and we can find a transaction. Each input of a transaction has a witness. It actually doesn't appear here, unfortunately. Okay, yeah. Each input has a witness, and the witness is what authorizes a transaction to be spent. It proves that you were, or that allows an output to be spent. It proves that you had the private key or whatever else was needed to spend that output. So the witness itself is, the part of the witness that we look at is Bitcoin script. It's a little script thing that is the sort of tiny program that proves that you were able to spend the input. And it is a very, very simple little programming language. People don't know this. Bitcoin has smart contracts of a limited form, and they're implemented in Bitcoin script. And this page here, bitcoin.com or en.bitcoin.com, bitcoin.it/wiki/script shows you all the opcodes. It's a very simple little language. It has these like op-if, op-endif, op-return. And the way that a witness looks, or an envelope looks, is it's basically op-false, op-if, tons of bullshit, op-endif. And this op-false, op-if means that nothing between the if and the endif gets interpreted by Bitcoin. So here we have this like tons of bullshit, and we take advantage of this as the place that we put inscription data. So that's a general envelope. Inside of an inscription envelope, we have the protocol ID, which is just the string ord. Then we have the fields, and then we have the body. And the body is introduced by op-false, and then all data pushes after here are the body. And then before we have the fields, and we have a tag value sort of format. So you have a push for the tag, and then you have a push for the value. Let me go into the docs and just find the pointer doc. Yeah, so here's something with a pointer. And we have, this is the envelope, op-false, op-if, op-endif, protocol identifier, which is ord, op-push1, which is the field tag for the content type. Then we have the content type. Then we have a push for the pointer. And then this is the pointer, which is 256, 255. And then we have op push 0, which introduces the body. And then we have a push for the body. So this is a text inscription with the body hello world. So in the code base, this is handled in the envelope. An envelope has a payload, which at first is just a vec of U8s. So it is a list of lists of bytes. And first the envelope starts as a raw envelope, which is a list of where the payload is a list of lists of bytes. And then it gets parsed into an inscription. And an inscription has all of these fields on it. So we sort of have as this first step, we go from witness to raw envelope, and then we parse it into a envelope, parsed envelope, which contains an inscription. So this is obviously very critical for the whole thing. And this envelope parsing has been the source of many bugs and many cursed inscriptions where we didn't think of some edge case that, duplicate fields or incomplete fields, all sorts of weird ways that an inscription could be formatted. And so after much wailing and gnashing of teeth, we finally have what I think is a pretty robust envelope parser. I don't actually know if I have the wherewithal to do this now, since we've been going for a while, to actually comment the stuff. But yeah, this is the envelope parser. I guess I'll sort of walk everybody through the process. So if we go to the inscription updater, and we go to index envelopes, oh yeah, here's the updater. So there's the general updater. And then here is where we call index envelopes. Basically for every transaction in the block, we call the inscription updater with index envelopes. If we go to index envelopes, it gets passed a transaction ID, information about the input sat ranges, and it does this shit is hairy. This shit is fucking disgusting. This code is fucking scary as shit. But it calls parsed envelope from transaction. This gets the envelopes out of the transaction. So let's go to the from transaction. So what does this do? This calls raw envelope from transaction, which gets the raw envelope, which is just the pushes, nothing else. In the envelope, it iterates over it, and then it parses each envelope from a raw envelope to a parsed envelope. So now let's look at raw envelope from transaction. Okay. So Raf, I don't know if I have the juice to actually comment things, but maybe we just walk through the code.
Yeah, I think commenting takes too long, until you write the text and you have to rewrite.
Yeah, I've got to write and I got to edit it and I got to do all this stuff.
I also have for me, I have a hard cutoff at 7. I have to go, but you can just continue. Or,
yeah, I'll probably bail at 7 as well. Okay, so then this is how we extract the raw envelopes from the transaction. So we create this mutable vector, and then for each input, we get the position of the input and the input itself. We get the tap script from the witness. So this is extracting the script, if any. A taproot spend has a key path or a script path. You can spend a taproot output with a key, or you can spend it with a script. So if the taproot, if this witness has a tap script in the correct location, this is going to return sum, and we get some tap script. So okay, so we got a tap script. The envelopes live in the tap script. So then we do self from tap script. So this is raw envelope from tap script. And if we get some some envelopes out of this tab script. We add them to the envelopes and then return them so that they're processed by later on. So now we have to go to the self tab script from tab script function. So this is passing in a script. Again, we create this new vec of envelopes. And then we convert the tab script into a instruction iterator. This is an iterator that's going to iterate over the instructions of a script. A script is made up of a series of instructions. Can there be multiple envelopes? Yes, there can be multiple envelopes in a single witness, or there can be multiple envelopes in all the witnesses in a transaction. A transaction can have as many witnesses as our inputs, and every witness can have as many inscriptions as you want. Okay, so here we do self-instructions next. While instructions, if instruction is equal to what?
This is if it's the content. It's looking for the.
I don't think so. Oh, this is checking for the initial op false.
Oh, this is initial. Oh, yeah, true.
Yep.
Yeah.
So this says in the this is actually checking for this op false. So what this does is it iterates over each instruction, and when it finds a op false here, then it tries to parse it from instructions. So then if we go to here, I actually don't know why we have this in here. Like really we could do the, whatever.
Would it be helpful to bring up like mempool to see it there too, like a description transaction?
Sure, yeah.
I don't know if you can see very much in there. Or maybe we can, I don't know.
Yeah. If somebody wants to drop a link to transaction in mempool.space. So I'll keep going. So the first thing that it does is it sees if the next instruction is an op if, and if it's not, it returns none. And then it checks if the next instruction is a push bytes with the protocol ID. That's just ORD. If it's not, then we return. And then we initialize this pushnum variable. There's a couple ways to represent numbers in Bitcoin. So for example, the number 1, it could be represented as a special op pushnum 1, or it could be represented as op push bytes, and then like the array with the value 1 in it. So we accept either, but pushnum inscriptions are currently cursed, so we have to track if we've seen a pushnum inscriptions. And then we get this empty vector, which is going to be the payload. This is going to be the sequence of pushes that are actually in this payload. Okay, so if we run out of, we get the next instruction. So this loop is going to loop over all of the remaining instructions. So pussy bytes.
You got a hilarious typo.
Bussy bytes. Anyways, so this is going to loop over every instruction. And if we hit the end of the instruction stream, like that's it. This is not a valid inscription because it doesn't contain an op endif. So if that's the case, we return none. Here, this is handling the end. So if we go, okay, this instruction is an op endif, we've reached the end of the envelope, and we return what we have, which is the envelope. This is just the inset and the input and the offset. This is the payload. This is this vec of U8s that we've been accumulating, and this op pushnum. So here is this kind of annoying thing where we take care of special case handling all of the different op pushnums. We do it all here. These are all of the op pushnums. It's op pushnum -1, op pushnum 1, op pushnum 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And so what you can kind of see what we're doing here. All we're doing is we're setting this pushnum. For those not experienced with Rust, match is like Rust's switch statement. It's match, and then on the left-hand side, you have the value that you're matching against, and then the right-hand side is what you want to do.
And this is an option you're matching on. Like some and none is at the option type.
That's right. Yep.
Yeah.
So if we have gotten a op push num 16, we set push num to true, and then we push 16 into the payload. Generally, though, most things are going to be just push bytes. And so if we get a push bytes, we convert it into a vec, and then we push it into the payload. So that's actually the first step of the parsing. That's how we go from from parsing a stream of instructions to a raw envelope, which again is an envelope, and it contains this envelope struct, and it contains a vec of U8. So that's the raw data. So let's go back a little bit. And here's the function that we were at before. It gets the raw envelopes out of a transaction, and then it converts them with this map statement into a into an iterator of parsed envelopes. So let's look at the impl of from raw envelope for parsed envelope. This is a Rust trait, and this is the trait from, and this handles infallible conversions in Rust. So this converts from a raw envelope to a parsed envelope. So it takes as input the envelope, the raw envelope, and then
Which is a vec of bytes.
Yep. And then it finds the position of the body. This is looking for a empty push, which is up false, which indicates the start of the body. And it needs to be at an even position, because otherwise it is a tag value and should be ignored. So this finds the position of the body. This initializes the fields vec. We're going to store each field in this vec of U8s to vec of slice of U8s. This is going to be the tag, and this is going to be the values under that tag. This is the incomplete field. It's a bool, and an incomplete field is if we have a field tag followed by an op endif. So we have a tag without a field in the envelope. So here is just extracting the fields. So for item in envelope.payload, starting at 0 and ending at the end of the or the start of the body. Yep. Mm-hmm. And we iterate over length 2 chunks, so key value items. We match that item. If it's a key and a value, then we insert that field into this fields B-tree map, also known as like a dictionary in Python. Or default, we push the value. If it is a incomplete chunk, that means that it's just of the form key. We've hit the end of the envelope, and we have a key without a value. So this sets this incomplete field to true. Then we have to track duplicate fields. This is yet another way that inscriptions can be cursed. So we check and see if there are any fields that have more than one value. And if that's true, then this duplicate field thing is set. So then we start extracting the fields that we know about. This remove field function, it basically just gets the field values. If it's empty, it returns none. And if it's sum, it returns the value and removes it from the vec of fields. So here we extract the tags that we currently support, the content type, which is the content type string like text plain, the parent, which is the parent of the inscription, the pointer, which is the sat and the offset that it should land on, and the meta protocol tag, that's the meta protocol. If you want to write crazy, shitty meta protocols on top of Ord, set your meta protocol tag. Good way to recognize meta protocol messages. Then it removes the metadata tag. And also metadata can come in multiple fields. So it removes all of the values in the field and concatenates them into a single vec. So then we look over the remaining fields, and we look at the keys, and we see if any of the keys mod 2 or 0. So inscriptions has this odd way of dealing with upgrades. So we want to be able to add fields in the future. However, fields might modify the position of an inscription. And so we don't want a scenario where an old client and a new client disagree about where an inscription is, and the old client has an erroneous value. Like the inscription is in the wrong place, because you sort of trick somebody that they thought they had a valuable inscription in their wallet, but in fact they did not. So the way that we handle that is that field tags, which you can see up here, they're either odd or even. And if we encounter an unrecognized odd tag, that's fine. We just ignore it. It's something that you can ignore. So content type, parent, meta protocol, metadata, those don't affect the location of an inscription. And so if we don't understand them, we can just ignore them. However, even tags, and currently the only even tag is the pointer tag, that modifies where an inscription is. And so if we don't understand it, we can't ignore it, and we have to make the inscription unbound. We have to report to the user that we don't know what the location is, which is safer than reporting an erroneous location. So this is the code that does that. It looks through the fields, and these are the fields that haven't been extracted. And we look at the tag, and if the key in the tag is the least significant bit of the key of the tag, mod 2 is 0, then it's even. And if there are any of those leftover fields, then we set this unrecognized field thing, this unrecognized field bool. And this will lead to the inscription being cursed in the inscription updater.
Yeah.
So then we construct the envelope. It just takes the input offset and push num from the raw envelope. It gets the fields, and then it gets the body, which is just getting the envelope from the start of the body to the end of the body, and then collecting them, flattening them, just concatenating all of the data pushes that made up the body. And that is what eventually gives us an inscription. Here's the inscription. You can see all of the fields on here. And I guess the next interesting thing is, like, how do those fields get converted into like their values? Like, some of these getters are kind of interesting, but maybe we won't go into those. Yeah.
Is that why the fields, there were some curse inscriptions that are unbound, right? Because they use the even number.
Yeah, they
So,
use
like,
an unrecognized even field. That's the
Yeah.
op66 people.
Yeah.
Yeah.
Thorn at our side, the op66 cursed inscriptions.
Yeah. Like, yeah, and unrecognized even fields we decided to make unbound, which means we recognize them, like we give them an inscription ID, but we can't bind them to a SAT because we, as Casey explained, we reserve like these even tags for protocol stuff that could maybe change the location of an inscription. So we can't really put them on a SAT, since they could, like old versions could then not kind of put them on the right SAT, and then things get ugly.
Yep.
Yeah. So yeah, I mean, I think that's a good place to stop. I think we went from really outside, like the periphery, like from the front end, like doing some like displaying and syntax highlighting of something in the front end, all the way down to kind of the heart and core of what Ord does. I think this was a really great overview. Yeah.
Thanks everybody
So,
for
yeah.
joining us. This was awesome. We got like 90 people in here. That's crazy.
Yeah,
that's fucking
more
awesome.
than I
That's
expected.
great. Yeah.
I thought maybe 5 people would join.
I'm
Yeah.
so glad you guys are doing this. This is what the people need. I mean, you don't have to do this. I know you guys are kind of finding your footing here, but wouldn't it be cool to be doing this regularly?
Yeah. Yeah, I think we
could do
definitely
this,
should. Yeah, I think the thing that will help us do this regularly is just having good issues. Like, sometimes we have issues which are like, just like me and Raf are just like flailing for like 2 hours, just like suffering through, like, we don't know what the fuck we're doing. We don't even know what the fucking problem is. Those would be pretty bad streams. They'd just be really demoralizing. Like, I don't want to have to flail in front of 90 people. But yeah, just having good issues. I think me and Raf are definitely open to doing this regularly. I mean,
Yeah.
I'd be cool if we could do this like once a week, or like once every 2 weeks or something like that. But yeah, this is good.
Yeah.
And also, I think it's good for new contributors, you know, and also like just like knowing how the fuck everything actually works, like where the rubber hits the road.
I think the more
Yeah,
you
yeah.
guys talk about it, the better issues you'll get, which means the better you can talk about it, which means rising tides.
Yeah.
Yep, totally.
Awesome. Yeah,
Cool.
it's great.
All right, I
Awesome.
guess let's wrap it up. So yeah, thanks everybody
We wrap it
for
up. See you in the next stream.
peace.
Adios, everybody.
Hey guys.
Peace.